very good evening. Okay, we are back with class 12 chemistry. Okay, with unit number 9. Okay, which we were doing in the earlier lecture. This is your lecture number 4. Okay, got it. In the last lecture we have done the this. In the last lecture we have completed the IUPAC naming and all those things. Now here we are going to study about the isomerism in coordination compounds. So what is isomerism in coordination compounds? So see here, two or more compounds having same molecular formula. Okay, if there is two or more compounds which has the same molecular formula but different arrangement of atoms are called as isomer. Okay, but different arrangement of atoms are called as what? Isomer. And the phenomena we call it as what? Isomerism. There will be two coordination compounds which will have same molecular formula, only what will be the difference? The arrangement of the atoms or the molecules will be little different. So those two compounds we will call it as what? Isomer, and the phenomena we will call it as isomerism. Okay, now here we are going to discuss about types of isomerism. Okay, so what are the types of isomerisms? So their isomerism can be divided into two. Okay, one is structural isomerism, another one is stereoisomerism. Okay, in the structural isomerism again we have divided into four. The first one is ionization isomerism, second one is hydrate isomerism, third one is coordination isomerism, and the fourth one is linkage isomerism. Got it? Next here, stereoisomerism. Stereoisomerisms are divided into two types. One is geometrical isomerism, another one is optical isomerism. Now we are going to study about this structural isomerism one by one. Okay, it describes each of the type of structural isomerisms along with their definitions we are going to understand. So the first type is what? Ionization isomerism. So in ionization isomerism you will find that it is a structural isomerism. Means what? Ionization isomerism is a part of what? Structural isomerism, in which two or more compounds, they have same molecular formula but produces different ions in solutions. The two compounds, these two compounds you see, if you see here CO, CO, NH3, 4, NH3, 4, Br2, here also Br2, Cl2, Cl2, means what? Their molecular formula, their structural isomerisms in which their molecular formula is exactly same, but when they dissolve, when they are dissolved in this, when they are dissolved, the ions which they produce are different. Here, when they will be dissolved, they will be producing the ions. This positive, how much? It will be 2 positive, and this one it will be 2 Cl negative, right? Here the ions is what? This is the ion, right? Here ion is Cl, but here when you dissolve this one, it will produce 2 positive, but the ions which they will produce is 2 Br negative. So here ion is what? This is the ions, right? So you can see clearly that in both the cases their molecular formula is same, but when they are dissolved in the solution, in a solvent, the solution in the solution form, they are giving different ions. Here it is giving chloride ions, here it is given Br ions. So their ions are different. So this kind of isomers are called as what? This kind of isomerism we call it as ionization isomerism. Okay, ions should be different. Next, second type is what? Hydrate or solvent isomerism. So hydrate or solvent isomerism is what? Let us try to understand. It is a structural isomerism in which two or more compounds will have same molecular formula. Everything is just same, only little bit difference will becoming molecular formula, but different number of water molecules in coordination sphere or outside it. Means they will have same molecular formula, but the number of water molecules will differ either inside the coordination sphere or outside. It will differ in number of water molecules. Okay, so see here CrH2O6 Cl3, right? So here water molecules is what? Inside the coordination sphere it is 6, but here you see inside the coordination sphere how much water molecules are there? Only 5. and outside is 1. So everything is same here. Cr, Cr, H2O6, H2O6, Cl2 and 1, Cl3, Cl3 here. Same everything, but only it differing in the number of water molecules inside the coordination sphere. Here inside the coordination sphere, how many water molecules are there? 6. But here how much? 5. So these two coordination compounds, we will call it as what? Hydrate or solvent isomerism, because that is they have same molecular formula, but they differ in the number of water molecules in the coordination sphere. This inside the bracket, the number of water molecules in both is different, so they are called as hydrated isomerism. I hope you understood. Next, linkage isomerism. So linkage isomerism is what? It is a structural isomerism in which two or more compounds have same molecular formula but differ in linkage of atoms of ligands bonded to central metal atom. Means what? See here also CO, NH3 3 times, NH3 3 times, NO2, NO2, and here Cl2, Cl2. Everything is same, right? Only they are differing is what? Here the linkage of nitride will be done through N. Here the linkage with the central metal atom will be done through N, and here the linkage will be done through O. Here the linkage will be done through O. So they differ only in the linkage of what? Ligands to the central metal atom. Here the linkage of the ligand is done through N. Here the linkage of ligands is done through O. That is the only difference. So this kind of isomerism, we call it as what? Linkage isomerism. They only differ in the linkage of ligands with the central metal atom. Here in this compound you can see the linkage is done through nitrogen. Here the linkage is done through oxygen. That is the only difference. Remaining everything will be, molecular formula will be same, but they differ in the linkage of ligands to the central metal atom. Okay or not? So this kind of isomerism, we call it as what? Linkage isomerism. Okay, now moving on to the next one. What it is? It is the structural isomerism in which two compounds have same molecular formula. Everything, everywhere it is same molecular formula, but different central atom in cation and anionic part. So as I have told you while doing IUPAC, the first one it will be positive, the second one will be negative. Positive, negative, right? So in the cationic part, here you see the central metal is how much? Is what? It's cobalt. In the anionic part, you see what is the central metal atom? Chromium. Okay. Now another one you see here. Here the cationic part is what? Chromium, and anionic part is what? Cobalt. So if you compare, everything is same. Their molecular formula it is same, but only they are differing. Here the cationic part, the central metal atom was cobalt. Here the anionic part, central metal atom was Cr. But in the other one you see, in cationic part the central metal atom is chromium, and here the anionic part you will see the central metal atom is cobalt. Just opposite to each other, right or not? So this isomerism, we call it as what? Coordination isomerism, in which only they will differ in the cationic and anionic part. The central metal atom will differ. Entire molecular formula, everything will be same. Okay. Now coming to the structural isomerisms done. Now stereoisomerism. So what is the stereoisomerism? So it is the isomerism in which two or more compounds have same molecular formula, but they differ in spatial arrangement of groups in 3-dimensional space. It is of two types. Okay. So stereo means nothing but space. Okay. So that means you can say that the arrangement of the different groups in the space, we call it as what? Stereoisomerisms. Okay, but they will have the same molecular formula, but they will differ in the spatial arrangement. That is nothing but 3-dimensional arrangement of the groups or the ligands. It will be different. in both the coordination compounds. So those kind of coordination compounds, we call it as what? Stereoisomerism. The molecular formula is going to be same, but spatial arrangement of the groups in three-dimensional space will be different. Okay, so these stereoisomerisms we have divided into two types. Number one, geometrical isomerism. So what is geometrical isomerism? So remember, it arises in heteroleptic complexes. As I have already explained to you what is heteroleptic complexes. Heteroleptic complexes are those complexes in which the central metal is atom is attached to different types of ligands or bonded to different atoms. Okay, those are called as a heteroleptic complexes. If you have doubt in heteroleptic complexes, dear students, don't forget to watch class 12 coordination compound unit 9 lecture number 2 in your channel Kumar sir. It is available. You can go and watch the video. You will understand. It arises in heteroleptic complexes due to the ligands occupying different position around the central metal atom. So called geometrical isomerism, it is valid only in what? Heteroleptic complexes, in which you will find that the ligands are occupying different positions around the central metal atom. In such kind of coordination compounds, we will see this geometrical isomerism. So geometrical isomerisms, in that also we have two forms. The first form is called cis form. In cis form, what will happen? The ligands occupy the adjacent positions. The ligand occupy the adjacent position means, suppose this is cobalt, here it is Cl, here it is NH2, suppose, and here it is Br. So this is called as what? Adjacent positions. So if such will be the case, then this type of structural isomerism or geometrical isomerism, we will call it as what? Cis form, when the ligands occupy the adjacent positions. Okay. Transform, when the ligands occupy the opposite positions. Suppose here the ligands is placed here. The same compounds, the ligands, it is placed, suppose here. So this is opposite to each other or not? So this one, you call it as what? Transform. This one you remember it, very important. You will get in your exams questions, 2-3 mark questions to draw the structure of it. So all of you should understand properly. Once again, cis means when the ligands occupy the same positions adjacent side, and trans means when the ligands occupy the opposite positions. Okay, note. So one important note is there. Everywhere it is not, this cis and trans is not valid, so you should know this isomerism is not possible in tetrahedral complexes. So tetrahedral complexes, in the tetrahedral complex you will not see this geometrical isomerism. Now what is the reason? The reason is because they do not possess element of symmetry. In tetrahedral geometry, tetrahedral complexes, you will see that they cannot be equally divided. Okay, in tetrahedral geometry you can see that the ligands cannot be equally divided. Like here you see 1, 2, 3, 4. 4 are there equally, it is symmetrical element, so we can go for geometrical isomerism. But if it is unsymmetrical element, we cannot go for this geometrical isomerisms in unsymmetric elements. Okay, this one you have to remember. Tetrahedral complex is what? Does not possess an element of symmetry. That's why in that geometrical isomerism is not possible. So geometrical isomerism is only possible in square planar and octahedral complexes. Okay, geometrical isomerism is only possible in square planar and octahedral complexes. Remember this. Okay, now we will do the second type. Okay, before going to the second type of stereotype isomerism, let us first discuss the geometrical isomerisms some examples and their types. Okay, we have already discussed that geometrical isomerism, they are capable of forming cis and transform only with the square planar complexes. It is not possible in tetrahedral and octahedral complexes, right or not? Why? Because the element do not form symmetry, right or not? That is the reasons why tetrahedral and octahedrals cannot form this geometrical isomerisms. So all of you please remember the reasons. Okay, if you don't remember, who knows, it may come for 1 mark and choose the correct. Okay, so now we are going to see some examples of square planar complexes, their structure and types of square planar complexes. Okay, we are going to discuss in this one. And remember, dear students, this structure, this geometrical structure of these compounds, examples which I have taken, it used to come in the exam last year also. It is asked in NBSc to draw the geometrical isomerism, okay, of some compounds. So for that it was allotted 3 marks or 2 marks. So dear students, try to understand it properly. Okay, next the type 1. So in the type 1 we are going to see Ma2X2. Okay, now what is Ma2X2? M indicates metal atom, central metal atom, maybe cobalt, platinum, iron, anything. This M indicates metal. A indicates what? See here, where A and B also it will come in the coming examples. So where A and B are neutral ligands such as H2O, NH3CO, NO, C5H5N, that means PY. Okay, so A2 indicates A is nothing but a ligands, neutral ligands, and X2 indicates the anionic ligands, that means the negative ligands. This one indicates neutral, okay, neutral ligands, and this one indicates anionic ligands, or you can say negative ligands. Got it or not? So X represents anionic ligands, A represents neutral ligands. So here we have taken one like this type of one example. M, platinum metal atom, central metal atom here is platinum, and here our A2, that is what? Neutral ligand. So what neutral ligand we have taken? NH3, this is a neutral ligand. X2 is what? It's a negative, so Cl2 is a negative ligand. So this is square planar complexes of type 1. So this one, how to draw the geometrical structure. So cis form, as I have already discussed with you, in the cis form same type of elements will remain on the adjacent sides. So here NH3, it is remaining on the one side, Cl on the one side, right or not? So this is cis form of geometrical isomerism. And in the transform, as I told you, they will be opposite to each other. So NH3 will be opposite to NH3, Cl will be opposite to Cl. So this one is nothing but transform of geometrical isomerism. Another type 2 of square planar complexes is Ma2XY. So M, central metal atom, A2, neutral ligands, X and Y is nothing but anionic ligands, that means negative ligands. Both is negative ligands. So such example we have taken PTClPy. This is negative ligands. See here, it is in the list of neutral ligands. Sorry, it is in the list of what? Neutral ligands, A and B. So A is there, right? How many times? A 2 times. So Py 2 times. Neutral ligands 2 times. And X and Y. So X is Cl, negative ligands, and NH3 is also a neutral ligands. Okay or not? Okay, fine. Just once, let me check the example once. Okay, so here PTCl Py 2 times. Here this is neutral ligands 2 times, so 2 times, and then NH3. So this one again we have represented in cis and transform. So if you represent Py on the same side, another 2 will be on the same side, that is the adjacent side. In the transform you will see both the Py, it will be opposite to each other, and NH3 and Cl also, it will be opposite to each other. So this is the geometrical isomerism of these compounds and the structures. Okay, I hope you have noted down. Now we are going to see type 3 and type 4. Okay, got it? Type of square complexes are like this: MACD, MABCD, where ABCD, this is all, ABCD is nothing but neutral ligands. Okay, as I have already given it previously what is the meaning of ABCD, so you will watch it properly, and then you will come to know what is the meaning of ABCD, XY and all, everything I have given. Okay, so what is the speciality of this type of square planar complexes is that in this type of square planar complexes there are 3 isomers. Okay, earlier we have seen only 2, right? Till now up to type 2 we have seen only 2, but in this type of square planar complexes you will find geometrical isomer how much? 3. So the position of one ligand is fixed. So in this there will be 4 ligands, A, B, C, D, right? And 3 isomers they will form. So let's we will fix the position of A. A positions we are going to fix it. Okay, and other A, B, C, D will bring opposite to A one by one. First will bring opposite to A this C, then will bring B, and the last will bring opposite to A what? D. So let's try to see the example, you will understand better. So the position of one ligand is fixed and the others are arranged trans to it one by one. Trans to it means what? Nothing but opposite to it. Okay, opposite to it one by one. Example they have given, these are very important. Again I am telling you students, try to understand, nothing difficulties. Most of the students they leave these chapters. Even in the NEET exams you will have one questions from here, sure questions one will be coming from this chapter. So this chapter is very important. I am just teaching you the basic one. Try to understand, try to learn it. Most of the students I have seen that they says that coordination compound is very difficult. It is not at all difficult, provided you try to see, watch it and try to understand properly. Okay, so example we have considered this type of example: PET, our metal atom, then ligands NO2, then ligands PY, then ligands NH2OH, then ligands NH3, and here it is all positive. Okay, so first we have said that we are going to fix the position of one ligand, so I am going to fix the position of NO. Okay, so NO positions, as I have written here, fixed position. NO I have fixed, then next one B, then next one C, and next one D. Okay, then now what we'll do, C already came opposite to trans, that means opposite to NO2. Now C will change, C will go at this position and this one it will come at this one. One by one they will be opposite to it. So NO2, now PY will come here, NO will go there, and NH3 it will be still in the same positions. Okay, whole bracket positive. In the third isomers, what we'll do, NO2 it will be fixed, the position is fixed, then PY already has come opposite, NO2 already has come, but NH3 is not opposite, so NH3 will come and PY will go up here, NH2OH was there, that one will come here. Okay, so this is the third one. Always remember, in this type of square planar complexes, the first one you try to fix it, and other 3 one by one you place it opposite to the first one, that is A. Opposite, first I have placed opposite to A, C, then I have placed opposite to A, B, then I have placed opposite to NO2, that is A, that is D. Okay, got it or not? This is our A, this is our B, C and D. So see here, A is as it is, C was opposite to A. In the next example, in the next isomer, it will B will be opposite. In the next isomer, C will be D will be opposite to it. This one you remember it. Okay, very easy concept it is. Okay. Now another one is what? Now this square planar complexes, 3 types are there. We have discussed. Now we are coming to the octahedral complexes. So octahedral complexes, what is it? Type A, type 1 in that is MA4B2. A and B are nothing but neutral complexes. And remember, in square planar complexes the coordination number was 4. Okay, see here 1 2 3 4 coordination number all we have seen is having 4, but in octahedral we will find that the coordination number is 6. Okay, so here is the example CONH34Cl2. Okay, so next what we are going to do, first of all we will write the cis form of this. So when you are writing the cis form of it, see here the chlorine, both the chlorine are adjacent to it and all NH is this side adjacent to each other. Now in the transform you will see that chlorines will be opposite to each other. So the chlorine is opposite to each other and NH3 is occupying all the 4 corners. So this is the transform and this is the geometrical isomerism of these compounds. Okay or not? You got it everyone? So this is type 1. Now there are two types more are there on octahedral, then okay, complexes. So type 2, in type 2 you will see MAA 2 times B 2 times. So what does here AA means? So always remember this AA means whenever you will get a complex of like this types, always remember the structure will be this way. Okay, that is the only way to identify which one will have what kind of structure. If you get the complexes of this type, then you will go for this kind of structure. Okay, so AA is what? AA is symmetrical bidentate ligands. So symmetrical bidentate ligands, one example of symmetrical bidentate ligand is EN, PY, GLY. These are all symmetrical bidentate ligands. Okay or not? So we have written here our example. They are asking us to draw the geometrical structure of this one. This one already came in your board exam also. Remember student, it came in your board exams. Okay, so it came in your board exams in NBSC for 3 marks to draw the structure, this two structure. So COEN2Cl2, just see here exactly matching or not. AA means what? Symmetrical bidentate ligands. So EN is symmetrical bidentate ligands. So first we'll draw cis form. In cis form, EN, both the EN will remain one side and Cl will be on the one side. So Cl, they are adjacent to each other. Now En we will be drawing here like this. En, why we are drawing like this? Because En is a bidentate. One En is equal to, it will be occupying 2 positions. Okay, and that is why it is called as what? Bidentate. It can form a bond through 2 atoms. So bidentate. So these 2 position it is occupied by En, and again here this 2 position is occupied by En. Okay, got it or not? If you want to write the full formula of this ethylene diamines, okay, the full formula, then you can see here linkage will, how the linkage will be done, but that one will become little complex for you. For simple understanding for your board examinations, this is simple way, easy way. Okay, En it will occupy 2 positions here, bidentate, so 2 positions it is occupying. Here also it will occupy 2 positions. This is cis form. Now transform, En will be exactly opposite to each other. Cl also it will be opposite to each other. So Cl opposite to Cl, En opposite to En. You got it or not? Same method will be used in any compound. Here let it be anything, but same method we are going to follow it. Remember, dear students. Okay. Now coming to third types. The type third is what? MA3B3. Here you see how many ligands are there? 6. So coordination number is 6. Here also coordination number is 6. You might be thinking that the coordination number is for 2 and 2. No, these 2 and this is bidentate ligands. So 2 into 2 it will be how much? 4. 4 plus 2 is 6. That's why they are called as bidentate ligands. 2 means it is double 4. Okay, RHCl3 PY3 positive. So in this type, little bit different structure will be drawing. Same cis and transform. So chlorine will be together and 4 positions are there and 6. So chlorine will be together and this PY, PY and PY, they will occupy this side. 3 chlorine, 1, 2, 3, one side. PY, PY, it will be one side, and we will be joining it with a dotted line, making a triangle-like shape. So this is called as a facials or fake. This type of structure we call it as what? Facials or fake, and this is nothing but it is a cis form. Okay. Next, transform. These Cls will be opposite to each other. So this Cl has the Cl which was here, it will come here, here. So Cl opposite to Cl, PY opposite, and this one PI and one Cl will be opposite. So if you join this structure, this is called as meridional or mere. It is called as meridional or mere structures. It is nothing but transform. Got it or not? So this type of structures, students, properly you have to practice. Not only this, there will be many questions in your book. Try to practice those questions. Very, very important for your board examinations as well as your competitive examinations and all. Okay, so in today's lecture we will conclude here. Okay, we are done with the geometrical isomerisms. In geometrical isomerism we have done with the square complexes and octahedral complexes. In the next class we will be going for optical isomerism. Okay, their structures we will be studying, and we will be studying VBT theory. Okay, so dear students, I request all of you that if you have not watched the lecture number 1, 2, 3, then please go to the channel Kumar Sir, Chemistry, Class 12, Coordination Compound, Unit 9. You can start from there watching lecture number 1, 2, 3, and then you can come to this lecture. Okay, so that you will understand properly. If you are not able to understand in one go, watch the video thoroughly. Okay, it's not like you will click it, just watch for a few seconds and then proceed ahead. If you watch like that, then you will not understand anything. Thoroughly you have to watch it so that you can understand properly. If you have any doubt, feel free to ask your doubts in the comment box. Okay, and if you are new to this channel, please don't forget to subscribe and like the channel. Okay, I'm also trying my best. All of you, please try your best, give your best, try to understand and try to get a benefits from this